So lab 2.15. Imagine you were a new geologist hired. People all over the continent of the United States felt an earthquake, and it is up to you to determine the epicenter, the location of the earthquake, and tell it to the news channel. Remember, the epicenter is the point on the earth above the focus. So that's the point on the earth right above where the earthquake originated. How do you locate the epicenter of an earthquake? In this laboratory experiment, you will locate the epicenter of an earthquake by the process of triangulation. Huge word, simple concept, 3 points meeting. Form a triangle, and that's your point of focus. What do you think a seismograph records? So we all know that a seismograph records an earthquake, right? But what specifically does it record? The intensity, definitely, and it records those waves. So the first P waves it will record, of course, those are going to reach the seismograph first, and then the S waves, then surface waves. So you're going to get a P wave, and then some S waves, and then some P waves, and then some S waves, right? It's not like all the P waves get there, and then all the S waves get there. And the intensity of the earthquake as well. When you're looking at a Richter scale, I believe they measure the intensity. I think this is how intense it was. So the more intense an earthquake, the higher this peak here. They have a nice little formula for figuring that out that I wouldn't like to figure out. So use the lesson resources to figure out how to make the circles. The hardest part of this lab, it's really not complicated, Katie. It just looks like it is because it's 7 pages long. So remember, we only did the last 2 pages, just 6 and 7. You can print the lab out, which is what I suggest, and print only page 7. So if you do print the lab, just print page 7. You don't need to print all of it. Only 7 there's only page 7 that you need to write on. No ink, no problem, Emily. You can do it on the computer as well. It's 7 pages because it has really nice big pictures, okay? Well, the whole lab is 7 pages, but you only turn in the last 2. Wait, did you say 7? Yeah, I mean, there's really, have you opened the lab? It's like really cool pictures on the front, and then page 2 is half lake, and page 3 is 60% a graph, okay? If you want to save ink, I'm saying only print page 7. It's the only one you'll need to write on. You'll need the whole lab, but you can leave the whole lab on your computer and write on page 7. When you go to turn it in, I only need 6 and 7. That's all. Just turn in page 6 and 7. I don't need all the explanation in the front. So let's get started. Lab info. I only need the last 2 pages, like I just said. The lab asks for a protractor. If you don't have it, this is fine. Not a big deal. We have other ways. We have other ways for you to do that part of the lab without a protractor. Not a big deal. When you're doing the lab, you'll have to read the question and maybe go back to the examples, because the answers, I mean, they won't pop out at you. Sometimes I think you guys want the answers to pop out at you, and if that was an availability, I wouldn't be having a job. So they're not going to pop out at you. You have to look for them. All right? No, they will not pop out at you. You have to read the lab, folks. I have to actually read the lab, you might be asking. Gotta use your noggin. Yeah, you gotta read the lab. Basic concept. It happens, believe it or not. How to? So let's take a look at that lab. And let's scroll up to page 1. Wait, we're not going to skip to page 5? You mean we actually have to read this? Are you sure? Yeah, we got to read this. Okay. Follow the steps to get started. So in this lab, you will be using a method called triangulation. Remember, just 3 points to locate the origin of an imaginary earthquake. Use the directions below to get started. And if you need help, you have this nice little video. Watch this video for help if you become confused. Answer all questions thoroughly. Turn it into Dropbox by midnight on Sunday. Highlighted in yellow. I only need the last 2 pages of this lab. If you think you get confused, let me know. Let Ms. Moore know. We can help you. So answer the questions below. Interpreting a seismograph. It goes through what this picture means. So this is a picture, or, not a real picture of a seismograph like we saw before. So this is one that they've made for you. You can see the P wave arrived at 8:08 p.m. or a.m. It doesn't matter to me. It doesn't really matter in total. And the S wave arrived at, well, they probably use military time, arrived at 8:10:30. So 8 o'clock p.m., 10 minutes, 30 seconds. The difference between the two is 2 minutes and 30 seconds. So the first one arrived at 8:08. Second one arrived at 8:10 and 30. So that's 2.5 minutes between those 2 waves. That's an important part to know how to do. You're going to have to determine this later in the lab. Determining the distance to epicenter. So we figured out the amount of time between those 2 waves. It was 2.5 minutes. How do we use that to determine the distance to the epicenter? So we have the seismograph, the earthquake reader machine, in a certain spot. And at 8:08 p.m., it read a P wave. At 8:10:30, it read an S wave. So we can see how far away that epicenter is by using an SP wave interval chart. So this is on page 3 of your lab. So what you do is find 2 minutes and 30 seconds on the chart. Go up to 2 minutes and 30 seconds. Oh, they have a nice blue line for you. Go all the way over till you hit that line. Wow, that looks like a trend line. That's interesting that we just did a graph. Not hard even. Take some time. That we just did a graph where we had to make that line. Alright, so then you go all the way down to distance. So 1,600, and it's kilometers. P.S. They don't have that labeled there like they do for minutes. It's 1,600 kilometers. Right? What are we going to do with that? Reading the graph. So we figured out the time in between the S and P wave. We figured out the distance. The time was 2.5 minutes. The distance was 1,600 kilometers. Reading the graph tips and practice. So let's practice it again. The major lines you read on the y-axis are minutes. So look at your graph that should be in front of you. Go to 1 minute and figure out how many kilometers that is. So go up to 1 minute and figure out how many kilometers that is. Put it in chat when you see it. 600 what? Thank you, Aaron. Yeah, 600 kilometers. So that would go here. Okay. What about 45 seconds? Oh, that's not labeled on there. Jeez, oh, Pete. Up at the top, they told you each one of these little dotted lines was 15 seconds. So 15, 30, 45. Go over till you reach that SP wave interval line, and then go straight down. Who has it? 450. Awesome. 450 kilometers. 2 minutes and 45 seconds. Go up to 2. Put it in the chat when you figure it out. You can if you'd like, Ethan. It's the practice part. you were correct. Check your answer. And the last one, I thought it looked more like 1790, but they put 1800, so I'll go with it. But I would accept both if it were up to me. And we were correct. 600, 450, and 1800. It is upside down because they want you to do it first, and then check your answer. Step 3, locating the epicenter. So you found the distance from the seismograph to the epicenter. But you have to put that on a map, right? In order to figure out where it is. You have your starting point, but where would that ending point be? Locate a seismograph station on the map. Locate the scale on the map. They're asking you to do that. So we're locating our seismograph stations. We're locating that scale in the bottom left-hand corner. Placing your drafting compass. If you don't have that, that's okay. I'm going to show you another way to do it. You're going to draw a circle around each one of those epicenters and see where they meet. Because we need more than one data point. If it was just one data point, it would only be, I don't know, somewhere in one of these circles. But those graphs are all over the country. I know. It goes fast, I know. It is confusing. Give it a minute, all right? The first time I did this lab, I made mistakes as well. And that's okay. That's the joy of doing a lab. It's not going to pop out at you. You're going to have to dig down in it, reread, try again, erase, and that's fine. Don't become discouraged. All right? I've never done one of these before. Or maybe I have and I don't remember it. So when I did this one, I did make a mistake. I had to erase. And that's okay. So they've done an example for you. They've drawn those 3 circles for you. Now it's your turn to do it. So they have given you a seismograph that arrived at 3 different, below the seismograms that arrived at 3 different seismograph stations located in Helena, Montana, San Diego, California, and Dallas, Texas. And that's important because I had to answer a quick chat from Miss Moore. And that's important because the first time I did this, this part didn't sink in. And that's very important. I had to go back and look at that. P wave. So at what time did this P wave enter? We're going to do this first one together. 8:07. That is correct. So let's put 8:07 and no seconds right on the dot. What time did this S wave enter? Remember, we know that's a P wave because it's first. What time did the S wave enter? That's correct, Vera. 8:09. And no seconds. So what is the time difference between the P and the S wave in minutes? 2 minutes, that's correct. 2 minutes. So, what is the distance to the epicenter? Converting minutes to distance using the chart. Now, they gave you a chart down here. I didn't use that chart, it's too small. I went back up to the big chart, and I used that big chart. 2 minutes. Take a look. About right there. What did you guys get? Gary's got 12:50. Ooh, 12 might be a little short. Brendan might be a little short. Tristan got 12:50. That's what I got as well, was 12:50. So you would put that 12:50 yards. Oh, no. kilometers. Make sure we use that right one on there. Okay. Whew! That wasn't too bad, was it? Not too bad. This is fun. I was actually smiling by the end of this lab. This is fun. And I got to use a pencil. And I got to use a fun little ruler thing with tape and intervals, and I had a good time. And my kids weren't awake yet. So you'll do the same thing for this box, and you'll do the same thing for this box. And when you see all that data on that page, you're going to be super happy. Well, I was, because this is empty, and then we figured it out, and I love numbers and subtracting and graphs, and you're going to love it. So, once you have the distance to the epicenter, so this is the part that I had to go back and read again. Each one of these has a town on it. So the first one I'm going to do with you, Helena, Montana. So we go down to our map. And I put these markings on here. Your map doesn't have it. Let me share with you a quick way of doing this if you are able to print it out, and then we will go to the digital version. I did it both ways. So when I started this, of course, I had a blank page, and then I just got my whole package out, and I got this at Meijer for, I don't know, it was honestly like $3. So you can buy the pieces individually. I was actually just looking for this for a physical science lab, but I got the whole thing, and it was even better. So that's how I got started. Now, after I figured out, gave my answers away, that's smart. After I figured out the distance for all 3 points, I put them on next to my map, because I didn't want to have to flip back and forth all the time. And then, if you don't have a protractor, you can use your ruler, and I just put a piece of sticky notebook or notepad paper there, and I knew that Helena was 1270. There's a closer one. Where is it? It was. Oh, it might have been too fuzzy. Some of them were too fuzzy. So what I did was, because I didn't have a protractor, and you could just simply use a piece of paper, they give you that kilometer on the bottom, and then I marked it. So you can see my Helena is this third mark, and that's at 1200, did I say? Or did I say 1250? You're right, Tristan. It's at 1250. So I marked that on my piece of paper. And that's what I used to make my line. So I changed it. So in the first one you can see I didn't have the red dots, but I kept making mistakes. So I put a red dot to make sure I focused where to put my point. And so I would just use my ruler to make those dots as if it was a protractor. And so then I moved over here to the Montana one, and I did the same thing. I used the line for Montana. And I did the same thing for the Dallas, Texas. Make dashes every so often. I use the red dots to help me keep track of what dot I needed to use. Connected the dashes with a line, so it was a curved line. And then you can do your other two, and they will intersect. So you'll have 3 of them on your map, and these 3 will intersect at a certain point, which I do have for you. And then you put a star there. So I'm not going to tell you what star means. So let's go back to this. Some of you may be unable to print. No, the chart, Emily, is just for reference, okay? The chart is to figure out, you have the time, you use the time to figure out the distance. That's all the chart is for. if you are using Microsoft Word to make your circles, again, I put a red dot there just as a reference. Now, Microsoft Word is awesome in that you can insert shapes. So that's what I did to make my reference points. I also have one, I do believe it was San Diego. And then you can make your circle. You can right-click, format shape, and you can make it any color that you would like. So that's where I start. Now, Montana was, what was that distance again? 1290, 60, 12 days series, it was 1250. So, insert the shape. Now, I chose a line. You could use that little arrow if you'd like. And I made my line 1,250 kilometers long. Right? 1,250, yep. So there's 10, there's 1,000, there's 1,100, there's 12, and then there's 1,250. And when I release the click, it's highlighted. I have those green dots. And because it's highlighted, I can copy it. So I clicked Control C, and I made lots of those little lines. Control C, Control C, Control C, and then Control V. Can you see those little lines popping up there? And each one of those lines is 1250. Pretty cool, right? So if you're doing this on Microsoft Word, that is one, the radius. It's more so much stuff around. Yes, the radius. You can move that line up to your Montana. And what I did, because the line will get shorter or longer, however you move it, I did them right next to each other so I could keep them the same distance. And I did it kind of just like my check. Make another one at the bottom. Move this nice little friend. And this is going to take some patience. Is it going to just automatically be done for you? No. But sometimes it's nice to lose yourself in some data in some lab. Then revisit the world in a little while. So you can see it's going to create a little bit of a circle here. And you might be better at using the word shapes. You can insert a circle. You know, try to make it right over there, format it. Make it transparent. So right click, format shape. Can do that again for you, show you that. Right click, format shape. And then just turn your transparency all the way up to 100%. So your line is transparent. And just move your line to meet that. Move your circle to meet it. Okay? It's going to take some time and some fishing, and we don't expect it to be absolutely perfect, right? So we know that this radius is 1250, so you can keep measuring, move your circle, make more of those lines, and do it again for each point. So you have a Dallas, Texas point, and you have a San Diego, California point. And the whole time I was in San Diego, I thought we might have an earthquake. But it was so beautiful, I didn't care. Alright, so you'll have to do that 3 times, and your 3 circles will meet somewhere. And when they meet, you can insert a star wherever they meet. I'm going to format my star, and I'm going to make it blue. Alright, and then you can score 30. No, Lauren. Let me scroll up, Lauren, and show you. It's not 1250 for all. See each one of these? You see, Lauren, how Helena, Montana has its own seismogram. See, the whole station called seismograph. It goes like that. San Diego has its own. So the P wave arrival for San Diego is going to be much different. It is once you get into it. It takes some time to figure out, and but like I said, I really like this lab. So you'll have a different distance for all 3 points. I felt like an actual geologist. I pretended. Then you put all that data onto the map, and you will have, and you can say, look, I used triangulation to figure out where this earthquake originated. And it's going to be cool. Your family's going to be blown away. Using refraction and triangulation words. If you need help, let us know, right?